There we go. I believe we're live. I think we're live. So hello, everyone. My name is Megan Collins. Thank you for joining this afternoon webinar. Joining me today, we have Scott and Chris. Hello.
Hi, everyone. Hello.
I got to get my mouse over now. Today's webinar is really going to focus on our climate change building performance technology program, which is housed at our COGS campus, our Center of Geographic Sciences campus. Before we get into things, I will do just a little bit of housekeeping pieces. First and foremost is to do a land acknowledgement and acknowledge that NSCC, where I am today and where our campuses are located, we are located in Mi'kmaq, the unceded territory and traditional homeland of the Mi'kmaq Nation. Our relationship is based on a series of peace and friendship treaties between the Mi'kmaq Nation and the Crown dating back to 1725. As treaty beneficiaries, we recognize that we are all treaty people. I'll also do an African Nova Scotian recognition and recognize that, NSCC recognizes the African Nova Scotians as a distinct group who arrived here 400 years ago. From that time on, they have contributed to the infrastructure and economic wealth of the towns and cities they helped to build, but from which they could not benefit. Let us learn more about how our respective communities were shaped by the historical contributions of African Nova Scotians to Mi'kmaq. So welcome to the webinar. Today we're using a software called GoToWebinar. You should all have a panel on your screen that looks a little bit like what's being displayed in our session today. We've automatically muted and turned off your webcams. So if you are multitasking right now, maybe you are commuting, maybe you're walking the dog, making a little bit of lunch, you don't have to worry about your microphone accidentally turning on or your camera accidentally turning on. It's all been disabled. However, we do encourage you and want you to ask questions throughout the session. You can do that by using the questions tab on that panel that should be on your screen. I'll be monitoring the questions as they come through. Some questions I'll be able to answer on my own, but other ones I will communicate to Scott and Chris and we can answer them live throughout the session. Okay, so as we get into things, NSCC, I did mention earlier on that this program is located at our COGS campus, or Center of Geographic Sciences campus. We do have 13 other campuses across the province, which you can see on the map on the screen. Now, NSCC, we are the only publicly funded community college here in the province of Nova Scotia. We really emphasize on hands-on learning, career-ready learning that is connected to industry. So all of our programs that you see at the college, we have had communication, we have had conversations with our industry partners, with our government partners, to ensure and to see that there is a need within the province and within the country for folks to be going into careers and folks to be gaining the knowledge in whatever the skill set is. As we go through today's session, Scott and Chris are going to touch on what this program is, what hands-on learning looks like within this program, and what students can really gain from this program moving forward. So I guess this is where I pass things on to the two of you. So Scott or Chris, do you mind explaining what this program is and break it down a little bit for us?
Sure, I can take that slide. The Climate Change Building Performance Technology Program is focused on our built environment, which means buildings and the anthropogenic effect that humans have had on climate over the past few hundred years. So we know that buildings, houses, factories, commercial properties use energy. So some of that energy may be in the form of an oil boiler on site, or it may be electricity from Nova Scotia Power's supply for electricity. And that grid mix is made up of renewable wind energy, solar, but it's also made up of coal and bunker seek crude and some natural gas. So we look at how to build buildings better, how to be mindful about sustainability and efficiency as well.
Perfect. Okay, so the admission requirements, this is a graduate certificate, which does require folks to come into the program with some previous educational experience. Who's the ideal candidate for this program? We can see the admission requirements on the screen, but who's going to be ideal coming into this program?
Well, we've talked a lot about what an ideal candidate would look like for the program, and it's actually pretty broad. But ideally, what we would like to see is, of course, someone with an interest and passion for environmental sustainability and renewable energy and mitigating climate change. The knowledge and skills that would be the most beneficial coming into the program would be having a strong foundation in math, some physics, use of computer tools like Microsoft, Excel, etc. Past experience and knowledge of building and construction, how buildings are put together now, and perhaps some idea of some of the leading technologies that are out there. Yeah, so that pretty much covers it. Do you have anything else to add, Chris?
I would say don't be deterred if you don't have those pre-existing skills, and if you are determined and you like to take on challenges and you are able to grasp new technology and work through it. All of the courses that we will be providing will have good help packs. So there are help modules that would go along with any software that we would be using. And as a member of Nova Scotia Community College, as a student, you will have a free LinkedIn Learning account. And there is a wealth of knowledge there for any Excel, for example, that we would use often in class. You can log on to LinkedIn, and there are tutorials that take you right from the beginning steps of opening and saving an Excel sheet to performing calculations in cells.
Chris and I will, of course, be covering a lot of the fundamentals in class, but perhaps not in as much detail or depth as if it were a two-year diploma program, because as being a one-year graduate certificate program, we do have a lot of information to cover in the 2 terms that are allotted to us for that.
Yeah, it is a quick program, only 1 year in length, but it's good to see that folks can be coming in with so many different backgrounds and types of experience into the program. So looking at these sample courses, or some of the courses that students might expect to take within the program, can one of you or both of you talk to us a little bit about what these courses are? So what is measurement and verification, or what is building energy modeling?
All right, well, Chris and myself have been busy at work developing the content and courses for this program. So we're gonna split up this list by which one of us has been doing that. So the first course is one that I've been working on, building energy assessment. And as Chris mentioned in her introduction, our built environment, the buildings that we live and work in, are significant energy consumers and contributors to greenhouse gas emissions. In North America, our buildings contribute approximately 30% of our total greenhouse gas emissions on an annual basis. So in a building energy assessment, what that is doing is looking at an existing building and looking at the construction of the building, the type of engineering systems that are in the building, heating, cooling, electrical loads, etc., and performing an analysis and recommendations for how the owner of that building can reduce their energy consumption and their greenhouse gas emissions. And in Canada, there are a couple of programs that have pretty stringent requirements and methods for undergoing building energy assessment. Natural Resources Canada has a series of programs with that, and ASHRAE has guidance with respect to performing energy assessments on commercial and industrial buildings. So it's that information that we'll be using in part as guidance for how to perform a building energy assessment. That leads into building energy modeling. Once you have all of the physical and engineering information about a building, that information can be input into a computer model that can take weather data, climate data, and make predictions about how a building will perform under different scenarios. So if we make changes to the building, so we upgrade the windows or we add solar panels to the building, how will that affect the energy and greenhouse gas emission performance of the building over time? And under the building energy performance programs and criteria that we're learning about, there are also prescribed and detailed energy model software packages and methods for using those that we'll be using in and learning how to use in the course Building Energy Modeling. Under economic analysis, of course, dollars and cents figures very large in the decision making about which energy saving and improving retrofits to incorporate into existing buildings, or which advanced building techniques should be used in new buildings. So the economic analysis course will introduce the tools that can be used to compare different technologies, different approaches from a financial basis to see which ones are more advantageous for a proponent or client to go after. And we will be including in that course concepts and applications of carbon crediting and carbon accounting, because as we approach the need for net zero, there will be instruments in place where that will be required, and there will be financial instruments around accounting for carbon emissions and carbon offsets.
And then that takes us into building and climate science. So looking at buildings as a system. So looking at the building envelope, which is the exterior of the building that separates the interior conditioned space from the exterior unconditioned space. How can we keep that building envelope in a viable state for a very long time? So building buildings that will last years and years. So having heat recovery ventilators in the building to keep humidity levels low, and also being mindful of the mechanical systems in those buildings to heat and cool economically and efficiently. Looking at wall structure, so how do we build a wall to keep moisture out of the wall so that moisture doesn't migrate through that wall and create rot? And how do buildings, again, relate and impact to our climate? We can also look at the interior climate of a building. So interior occupant comfort, looking at indoor air quality. So all things looking at the building, how the building can be a safe, healthy space for occupants. And also looking at things like biophilic design, where we are building nature into the buildings, and how can that promote productivity and creativity for building occupants. So we look at the wide spectrum of buildings and how they're related to climate, but also that building science piece and how that building will operate with mindfulness towards efficiency. That takes us to building systems 1. This is my favorite. It's sort of the stepping stone to move through everything else. So we begin looking at how we can design buildings with efficiency and sustainability in mind. The textbook that's related to that program is the Canadian Home Builders Association's Builder's Manual, and that has chapters on building materials. It has chapters on vapor barriers and how we should build those into our walls, ceilings, and slabs to keep that building viable for a very long time. Look at different building materials. So alternative building materials, looking at the embodied carbon footprint or the negative impacts of, say, fiberglass compared to blown-in cellulose insulation, which is made from a recycled paper product. Looking at the different components of buildings. So what is an attic space? What is a roof? What's a wall cavity? And then we look at the R value, or the resistance to energy transfer through certain building components. So when we build a wall with studs and then we put insulation in the middle, that whole wall has variable pieces of material in it. So we can't say, okay, if I put an R20 bat in that wall is R20, because it's not. The studs have a much lower R value or resistance to thermal transfer. And that's where we do an average. It's called a parallel path. So we'll look at doing calculations to figure out what the actual R value of a wall or slab or a roof is. And then we'll take that to the whole building and look at U value, or how much heat loss occurs in the winter and how much heat gain occurs in the summer through the cooling months. That takes us to building codes and standards. The two main codes we will be looking at is the National Building Code of Canada and the National Energy Code of Canada. And then other codes that we would consider for that would be advanced building design. So things like passive house design, net zero design in buildings, and looking at how those codes can help us learn and build better. There are rebates available through some of the federal and provincial programs for increasing building efficiency. And then I'll pass it back over to Scott for high performance building design.
Yeah, so the next course on the list, high performance building design. In the program, you can think of it as really almost two streams. We're going to be dealing with existing buildings that we're going to be assessing and trying to improve their performance from an energy and greenhouse gas emission perspective. But then also we're going to be looking at how we design and build new buildings so that they are the highest performing buildings possible, the least amount of energy use and greenhouse gas emissions. And that's what the course High Performance Building Design is about. It looks at the techniques and methods that are used in the conceptual and technical design of a highly performing building. So we'll look at the integrated design process, which is an accepted standard in industry for getting all of the people involved in a building project, from the project owner to the tenants to the technical and tradespeople involved in the construction of the building, around the table at the very beginning, so that everyone is on board and has buy-in for the idea of constructing a building that is meeting very high standards for energy and emissions performance. The next course, measurement and verification. So all along through the courses, or through the courses that we've been talking about so far, is identifying ways to improve existing buildings and ways to design and build new buildings. And it's one thing to make a prediction or say that a certain activity or improvement is going to cause a certain reduction in energy consumption or a reduction in emissions. It's another thing to actually demonstrate that that is happening, and what is happening in industry in accordance with funding programs, rebate programs for businesses and individuals that embark on energy conservation measures, is that there is a requirement to demonstrate that the improvements that were identified and selected and implemented at buildings are actually working in the way that they were predicted that they would. And there are industry standards and procedures around those measurement and verification activities. And the measurement and verification in this industry is an entire dedicated field that graduates would be able to go and work in. Building systems.
Building Systems 2 builds on Building Systems 1, and we will get into looking at heat recovery ventilators, heat pump technology, sampling loads in the building to match renewable energy systems such as solar PV systems, so that we can keep that path to net zero. We want to be targeted net zero by 2050. So how can we put the existing buildings for upgrades, so renovations and upgrades to existing buildings with renewable energy in mind, but also when we're looking at from the design concept, Scott talked about integrated design process, design charrettes where you would have an architect, an electrician, a plumber, an HVAC specialist, and the homeowner all at the table with their perhaps their efficiency representative from Efficiency 1 looking at maybe a net zero design build. How can all of those building systems work together as a system? How you can put deadband into a program that's going to monitor building temperature, humidity, so that you don't have one section of the house is cooling while the other section is trying to heat. If you have a wood stove in a room and you have your heat pump set to automatic, if the room gets too hot and the temperature set point on the heat pump is, let's say, 21, and the wood stove creates a scenario where the temperature in the room is 23, that heat pump will kick in and start trying to cool the room. Well, we don't want that because that's wasting electricity. So looking at temperature monitoring systems, things like Nest systems. So it's a smart technology that you can put the app on your phone when you're away on vacation. You can look at your building back home to see, you know, are the lights on? Is the grid down? And if the grid's down, well, we have a generator. Is that going to come on automatically so the pipes don't freeze and burst? So looking at that, Building Systems 2, and how all of those components work together in synchronicity to achieve efficiency. Nature-based climate change solutions. So again, we're looking at, you're going to see a thread through most of the courses, pathway to net zero, looking at baseline emissions in a building, and then with that piece of monitoring and verification, recommending upgrades to that building envelope perhaps, or increasing the efficiency of the heating and cooling systems, and trying to reduce the emissions, number one. But then when we still have continuing emissions, because we're operating, we're manufacturing, or whatever that process is that's not totally accommodated through renewable energy resources, we can look at nature-based solutions to offset our existing emissions. For example, purchasing healthy, intact Wabanaki Acadian forests, and then mapping the carbon sequestration rates annually, and then the total carbon that has been stored over the lifetime of that forest. So looking at the built environment, mapping our emissions there, and offsetting any emissions that can be reduced. And then that's the so those are the main courses. And then we have a capstone project, which is a wrap up of all of the knowledge that you've learned throughout the year. Scott, I'll let you give an example maybe of some of the past capstone similar projects that.
Yeah.
Sorry, before you get into it, a couple questions come in, especially when it comes to our courses. Is the program specific to Nova Scotia / Canada building and making buildings and homes and facilities efficient, or can it stretch globally as well?
Well, certainly from a regulatory and code perspective, we're going to be teaching from a Canadian and Nova Scotian context. But the scientific fundamentals and the skills that the students will learn will be applicable anywhere in the world with regard to building energy assessment, building energy modeling, identifying and assessing and selecting energy conservation and energy emission reduction methods. So yeah, so we're going to be working within the Canadian and Nova Scotia regulatory framework, but the knowledge and skills are applicable around the world.
And some of the software that we will look at and learn about, so Passive House, for example, that's an international certification for high performance buildings. And the International Living Futures Institute, that's another global certification for not only buildings, but also communities. So those two would certainly apply globally.
Chris, you touched on my next question, actually. Which is what software will be used in the program, and is the program theoretical focused or practical oriented, where students will get hands-on experience?
Well, for the second part of the question, the course is both. It's both theoretical and hands-on. So the program is a bit front-loaded, perhaps, with the theory. So the building science, the climate science, the economic analysis, and then we get into the practical applications of actually going out and performing actual physical assessments on existing buildings and seeing how they are actually performing from an energy and emissions standpoint, taking those measurements, performing the analysis, identifying ways to improve those buildings. So I would say, in terms of theory versus practical, I would say it's about 50-50 how it's going to shake down. In terms of software, of course, there's going to be a lot of use of your standard business software, like the Microsoft Office suite of products. Microsoft Excel is used extensively in the industry, but there are industry-specific software tools that students will be learning about, specifically modeling and analysis tools. For instance, there's a product put out by Natural Resources Canada called Ret Screen Expert that we'll be using extensively. There's a again, put out by Natural Resources Canada, a building energy model for residential buildings called HOT 2000. There are different commercial level regulatory models for energy and emissions calculation that we'll be looking at. Chris, perhaps you can think of some more examples off the top of your head of.
Sure. So Energy Star Portfolio Manager, Scott mentioned the software that's used to map emissions. That's the go-to nationally and throughout North America. RightSoft, so the F280 assessment for heat loads in buildings and design layout for heating systems. The online heat pump sizing tool from NRCan. So those two softwares are required for the in-province off-oil to heat pump program through Efficiency Nova Scotia, where folks are able to receive some financial help to switch from an oil system over to heat pump technology. And then Scott already mentioned Excel, the entire Microsoft suite of software.
Also, while I think of it, you'll be using drafting software like AutoCAD and SketchUp to depict structures and take details off of those drawings to put into other software applications.
Perfect.
And to add one more piece to the hands-on, we have the Billigan House, and it's spelled P-I-L-I-K-N, but it's pronounced Billigan. It's a Mi'kmaq word for new house, new home. So we will be doing a fair bit of the hands-on at the Billigan, and if anyone is interested to learn more, if you go to NSCC site, type in search Billigan, you'll find some information about that home. It was designed by Soltaire, an architectural firm in Halifax, and it was built with a passive design concept in mind.
Excellent. Excellent. And we'll have a full slide on hands-on learning and what that looks like for the program. Just an example of the schedule for students to give folks an idea of what they can expect. So we see the schedule up on our screen. What are the expectations? Let's say on that Monday where classes are done at 1:30. Does that mean work is done at 1:30? Realistic. How much time outside of class should students allocate for schoolwork? Would it be realistic to work while they are studying?
Well, if you take the time on this schedule to add up the hours, the actual hours of class time works out to be 24. That's 24 what we call in the college contact hours, where Chris or myself are actually in front of you and facilitating your learning in person. That's only part of the story. What we say, depending on what sort of worker you are, we would say to typically expect total time per week, including the in-person contact hours, that you should be expecting to put in 35 to 48 hours per week on your study. And that will, the outside of class hours will be working on assignments and projects and other assessment deliverables for the courses.
Okay, good to know. So the hands-on learning piece, what does that look like for this program? I know the two of you touched on it a bit with the Billigan House, which we can see on our screen. But really, what is hands-on learning looking like for this program?
Well, a lot of the hands-on learning is focused in the building assessment area and the measurement and verification area. So in the building assessment area, that will be things like actually going to a building and in the absence of any drawings or descriptions of the building, actually taken physical measurements of the building so that the size and dimensions can be understood and recorded into the required software. As part of a typical energy assessment, there is a test called a blower door test, which is a physical test that is used to determine how airtight or leaky building is with respect to its building envelope. And that can, the results of those tests can provide direction towards improvements of a building envelope. So we have blower door kits on site and part of our equipment, and students will learn how to do these standardized tests for those building energy assessments. For building energy assessments, another tool, a common tool, is an infrared camera, which a normal camera sees visible light, just like you and I do with our eyes. What an infrared camera sees is heat, and how heat is being released and emanated from an object. So in a building assessment, that's useful to see where there are areas where more heat is being lost than in other areas, which can be used to identify areas of improvement. On the measurement verification side, where we're trying to either determine baseline conditions for an existing building or determine how a already implemented improvement is actually performing, there are devices called data loggers that can be installed that will measure things like the electricity consumption over time, so we can see patterns of consumption to determine whether things are working as they should. In the measurement verification area, a lot of use in the commercial and industrial end of building automation systems, getting and using data from those systems is used quite a bit as well. Actually, in the right-hand picture on the slide is a student looking at a building automation system that would be recording energy use data for a building.
Great. A question about the programs that are used. Are Revit and AutoCAD part of the program?
Yes. AutoCAD and Revit are their standard issue software across the college. So on the computers, in the computers labs and in the learning commons at the college, those two pieces of software will be available and will be used.
Great. Our next slide about job-ready skills. We talked a bit about hands-on learning and what that looks like for the program. How are we preparing students for industry in this program?
We've already discussed the different software skills that they will have coming out of the program. Going into a job, for example, as an EnerGuide evaluator, we will be walking through the technical guide for the EnerGuide assessment, using the blower door equipment to measure air change rates in the building, or the equivalent leakage area of all the tiny holes in the building made into one giant hole. If anyone can remember way back, I think it was 2012, the David Suzuki commercial where folks inside the building are saying, geez, it's cold and there's a draft. Can you make sure like you turn up the heat? And then, you know, the saw comes through the wall and the basketball comes through, and then it pops David Suzuki's head and he says, hey, did you know that your house is drafty? So we'll be looking at building assessments, monitoring verification, And we will be looking at not only residential but commercial buildings as well. We try to do at least one building audit in the community per semester. And again, looking at that whole building baseline, making recommendations for upgrades, and then looking at any offsets that might be required if we can't reduce the emissions down to zero with renewable systems. So the technical side is one part. Technical report writing will be a thread throughout all of the courses. So learning to write a technical report. Communications will be built into every course. So how do you interact with a client? How are you organized and efficient with your responses to an email inquiry? How do you make a schedule to go out to do an audit on a building, a residential building or a commercial building? So all of those are technical skills, but also integrated with soft skills.
If I can add to that, Chris, when Chris and I have been developing this program, all of the skills and knowledge that we're going to be covering are things that industry is explicitly looking for. Chris and I are in contact with industry all of the time, and they're telling us the type of knowledge and skills that they need for the workforce. So we're constantly in a dialogue with industry. Matter of fact, just yesterday, I was in a meeting with an industry partner, and we were talking about the new program and basically giving that industry partner a similar talk to what's going on here. And they indicated very clearly that the type of material that was being covered was exactly what they were looking for future employees for their business. And they wanted us to keep their name on the list for next spring when we have graduates leaving the program.
And another important piece I will add to that is public presentation, public speaking, creating PowerPoint presentations and delivering those presentations to your peers and faculty and clients that we will be working with is another big takeaway from the program.
Fantastic. So it sounds like students are getting a very well-rounded experience from this program. Everything from the hands-on piece, how to conduct these studies to get data, but also how to compose an email within this industry. Like, it's stuff that I think we forget is really important going into industry. And Scott, you mentioned a great point in how we are so, at the college, we're so connected with our partners, our industry partners, and create programs that reflect the need and the demand within the province and within Canada as well. So talking briefly about international learning, this program is open to international students. Is there an opportunity for students? I guess we talked about this a bit, where the program is really covering Nova Scotia provincial and Canada national code. Is there a possibility for students to do international exchanges or international opportunities?
Absolutely. So NSCC International has various programs globally, some of which are based on energy efficiency and that global transition to net zero. So last May, the end of May, first week of June, I was fortunate to travel to the Netherlands and attended the Hanze University for 2 weeks with 2 other students from NSCC. And it was called the Global Energy Transition Program. It was a three-week, sorry about that, 3-week program that involved, I think there were 12 different countries that had representative students attending and faculty. So that was an absolutely wonderful experience. Students are able to learn the culture, perhaps pick up a bit of a new language and learn how other countries are approaching and mitigating climate change and what those different impacts look like in different areas of the globe. So comparing Kenya to Nova Scotia, to the Netherlands, to France, to Australia, and looking at all of the working parts that have to work together in order to approach climate change resulting from global warming in a constructive, technological, methodological way to help everybody learn together. And it's an awesome opportunity for students to see, what we have for resources here and what other countries may have for resources and how they adapt maybe to fewer technology based resources. And Scott was on another great.
Yeah, just my international experience with NSCC students. I had the opportunity to go with students to Africa on 2 occasions to work on a sustainable energy and climate change related project. So very different experience and scenario than going to a university city in Europe. This was in remote rural Tanzania. So NSCC International is a department of the college, and they do a great job of creating opportunities for students to experience international learning that relate directly to their field of study.
That's perfect. And it really sounds like those experiences have helped the 2 of you in your teaching to see those global experiences and reflect on those.
Absolutely, yes.
Yeah. So we've had a few questions about job prospects. Now, this is a brand new program. However, we've had a program that is a little bit similar and has influenced this program. So being a brand new program, what do you expect the demand or the job prospects to be like?
We expect the job prospects to be very strong coming out of this program. You made mention of a previous program that had a similar alignment to this program. That program being sunsetted, but out of that program for the past 4 years out of that program, we had a 99% employment rate in the field out of graduation. I mentioned that I was speaking with a industry partner yesterday, and they mentioned only half jokingly that they would hire every one of our graduates next spring. So there is a high demand for people coming into this industry with the knowledge and skills that you'll be learning in the program.
If anyone that is logged in is familiar with Efficiency One or Efficiency Nova Scotia, currently from the previous program that was Energy Sustainability Engineering Technology, or ESET, there are currently 17 graduates from that program, all employed with Efficiency One, so in various roles.
Yeah, and I think that's great for folks considering this program to hear that there is a demand. So a question about job opportunities. This question has a number of questions within it. So what information do you have about numbers of prospective jobs for graduates? What would the job title be for these positions? So I guess some example job positions. Expected salary, which I think can be pretty tricky. Where are the positions? And would someone with no related experience or other related qualifications be competitive for the job?
To answer the last one first, a graduate from the new Climate Change Building Performance Technology program would definitely have a leg up on someone without that background, 100%. Did you want to speak to some of the other questions?
Yeah, so the types of jobs that graduate program could be going into would be a building energy advisor, so performing building energy assessments either under the NRCan home retrofit program or commercial and industrial building energy retrofits, working with consulting companies, performing measurement and verification activities for mostly commercial and institutional and industrial clients, being involved with or working for design build firms as a sustainability manager, leading the climate change and sustainability related activities of new build projects. So being something like a commissioning agent or a role like that in an integrated design environment. As far as salaries go upon graduating, the range is expected to be anywhere from $40,000 to $60,000 per year. That's what we've seen with previous graduates from the similar program going into similar areas. So did that address everything, or did I miss anything?
I have one thing to add to that too. So thinking about Efficiency Nova Scotia with 17 past ESET grads, you could be an energy advisor working on the phones, which is a remote position. So you may live in Yarmouth and work for Efficiency One. You might be a program manager under Efficiency One. They have different sectors. So they have aquaculture, they have agricultural. So you would go out to a farm and you would help them reduce their energy costs. And in relation to reduction of those energy costs, you would also be reducing their emissions footprint. Embedded energy advisors. So CFB Greenwood has an embedded energy advisor from Efficiency One, and again, they are on site to help those large organizations become more efficient. Another opportunity is working in the heating, ventilation, air conditioning sector as an energy modeler. So the new programs that are coming out with rebates attached require energy modeling on the buildings that the new heating systems are going into. And also sales and marketing for energy efficiency upgrades in perhaps solar PV systems, or again, in the HVAC industry with heat pump sales and HRVs.
Perfect. And I'm sure some of the jobs don't exist yet as we move into.
Yes, I see great things coming for balanced emissions mapping.
Mm-hmm. Yeah. So some of these titles may still be in the works. Yes. Program fees. So the costs on your screen are going to reflect the current academic school year for a graduate certificate. Fees for the 2024-2025 academic year are going to be released usually later in the spring, early summer, but we don't expect them to be too far off from what you're seeing on the screen. So tuition for a graduate certificate, $5,540. But on our program fees page, we also list some additional program costs. These are estimates for things out of pocket you may have to pay for, whether that's textbooks, technology, etc. What additional costs can students expect in this program?
There is one textbook that will be purchased from the campus bookstore, and that is the Canadian Home Builders Association Builder's Guide, and that's $68.75. So that would be one additional textbook. The rest are all online or in open educational resources, so there would be no fee for additional textbooks within the program.
Another line item that is on the additional cost is it's called the Maple Mathematics software, and it's essentially a really powerful graphing calculator that is on your desktop or your laptop. So it's intended to replace the graphing calculator that you might have as a separate device.
Excellent. We really do kind of go on the higher end when we are listing these estimates. So Chris, I think you said that that guide was 65 something at the bookstore. So we try to give costs that are going to reflect wherever you're going to buy these items, and our bookstore tends to be the most affordable place for books and guides and etc. We also include a technology requirement in there. You're not going to purchase a laptop through NSCC, but if you do visit our program fees page, you can see the requirements for a laptop to ensure that the laptop that you have is adequate for the program. So scholarships and bursaries, kind of going hand in hand with the cost of the program. We want students to be applying for every single scholarship, bursary, award, or opportunity that is open to them. We have over $3 million in scholarships, bursaries, and awards, and a lot of it goes untouched. So if there's anything that you take away from this session, in addition to all the excellent information about the program, please apply for every award opportunity that you see. Typically, students are applying for these once they're confirmed in the program. You've already applied, you've been accepted, and you've confirmed your seat. Chris, do you know of any specific awards or scholarships for this program?
That's a question that I cannot answer, but I do know that there are, and I can't remember the names of them, but there are bursaries for training on software within the former program that was related to building climate science. I'm not familiar with the upcoming awards that will be related to the new program, but there were 3 students in the last program that was related to building science that were awarded several bursaries throughout the year to help with additional training for software red screen certification. Yep. and LEED certification. So those 2 softwares are related to a certification for building assessors to achieve.
Perfect. Sorry, I put you on the spot there.
That's okay.
And applying for awards is quite simple. You do one general application and we will automatically match you with awards, and then suggest other ones that you would be eligible for that have additional requirements. So it may require a write-up, it may require a reference, but regardless, apply for all of it. We want students to be receiving this money, of course. So services and resources, student success is of course the most important thing at NSCC. Class sizes are quite small. I think within this program, how many students are in the class, or do we expect? Under 20, I'd say?
There's a cap of 15 for this year.
Okay, yeah, so quite small, where you really do get to know your faculty. So Chris and Scott, you get to know them and build that rapport. And our faculty do get close to students. So if there is something going on that is preventing you from getting to class, or if you are not understanding the content, maybe it's not the best fit for you, your faculty tends to be your first point of contact. But outside of faculty, there's a range of services. So our library services, student services advisors for each grouping of students, We have our Indigenous and African Canadian services, advisors, counseling, personal counseling, career counseling, accessibility, you name it, we've got you covered on campus. The COGS campus itself is quite small as well, so it's a very family-like environment to be in. Anything to add to that, Chris?
I do. So I've been teaching in this field for 5 years, and what I've noticed is that the class dynamic that I've experienced over the past 5 years, every year, the students become a small family. And for the past 8 years, the previous similar program made up the entire student association for 8 years running. So very motivated groups tend to enroll in this type of program, and they like to have fun. And they are so kind, they always invite faculty to come along and have fun with them. So some of the activities we did last year, we went skiing at Martok. They hosted a haunted house at the Billigan. And we like to learn and have fun. So putting those two hand in hand, you'll quickly learn to lean on everyone's skill set in the class. So someone might be coming in with a project management background. We've had professional engineers, international students come into the program. So one year we had 3 professional engineers in the class. So relying on your fellow classmates for help and support is something that will seamlessly happen.
Yeah, and that's such a great environment to be in as well. It's not just school.
No.
This is your life. So enjoying it while you're doing it is really important. With that said, we also have campus housing at COGS. So this is one of our newer campus housing locations. Whatever you have seen in movies and TV about what campus housing looks like, I dare to say that this is not going to be that. It is brand new. It is beautiful. It's apartment style, so 1, 2, and 4 bedroom apartments. Most students are going to be in the 2 or 4 bedroom apartment style space, where you have your own private bedroom. You share a couple of washrooms with your housemates, and then you share your kitchen, living room, all the furniture is in there, internet, etc. So it's a great place, and it's right next to where your classrooms are. So it's easy peasy. Becoming a student, so as we wrap things up, applications can be submitted online. For domestic students, there is no deadline to apply. We are assessing applications as they come through. International students, the deadline to apply was April 1st. However, if you are currently in Canada with a valid study permit, we do encourage you to send an email with a copy of your valid study documents at nscc.ca to submit that application. The cost to apply is $40 for domestic students, $100 for international students. When it comes to your documents, your transcripts, those can be sent directly from the issuing institution to documents at nscc.ca as well. And finally, there we go. I encourage everyone to stay connected, follow us on our social media channels. We do day in the lives on our Instagram. We answer questions on Facebook so that you can get a better feel of what NSCC is like. We've had plenty of questions come through throughout the session, which is excellent. We love to see questions. And I think if one person is asking questions, it likely means that other people who are attending this session have similar questions, which is awesome. So we'll open the floor to more questions if there are any. And Chris, do you have any final thoughts or final things you'd like to add?
Sure. Climate anxiety, I think affects most people. I'm working in the industry, so I know in my small cohort, it affects everyone differently in various degrees. If you're feeling stressed about climate change and global warming, this is a great opportunity for you to learn the skills to be part of the solution. And then on that same note, Lawrencetown, where COGS is located, and this is Lawrencetown, Annapolis Valley, not Lawrencetown outside of HRM that has a great surfing beach. Some people have come there and thought, oh shoot, where's the beach? It's a wonderful small village. There is Lund's Mill, which is a little microbrewery. There's a Bee's Knees general store that has everything from cheesecake to bread to handmade earrings. There's a library in that town. We have outside of COGS, we have a solar array that we will be looking at to map, what that generation looks like. We have gardens at COGS, and we also have about 150 acres of medium growth forest behind the campus with a trail that goes right down through the middle of it. So we will be working in that forest, looking at carbon measurements and samples to calculate how much that area sequesters and has stored over time. So lots of outdoor time, beautiful, beautiful spot. If you've never been to the Annapolis Valley, it's a lovely spot. We're right about 15 minutes from the Bay of Fundy, which has the highest tides in the world. And it's a community-based campus, small town, and the folks here are just wonderful, and they all love students. So we would welcome you and be very fortunate to have you join the program at COGS.
Thanks so much, Chris. That was so lovely to hear. Sharing a little bit about the town and where students would be living. I don't see any other questions coming in, but if folks do have questions, feel free to send them to recruitment@nscc.ca. We can forward them off to Chris and Scott if they're related to this program. If not, we'll answer them. But thank you so much for spending the last hour with us and taking your lunch hour to listen about NSCC. And thank you, Chris.
You're welcome. My pleasure. And Scott had to pop out because he has a work experience check-in that was scheduled for 1 o'clock. So
perfect.
He says bye. Thanks very much.
Thanks so much, Chris. Bye for now.
Bye-bye.